Alright, good morning, year 11s. We continue with chapter 7 on transformations. With 7b, we're going to look at two types, which would be dilations and reflections. With the dilations, they will be from either axis. With we'll look at the rules and how the function will look like after it's been transformed. And then the last two will be the reflection in the horizontal axis and the vertical axis. Alright, with the first one, it's a dilation from the x-axis or horizontal. So in this example, if you have a dilation of factor 2, what you'll get is doing the mapping of coordinates. You start with your x and y. The new y coordinates, it's 2 times the original one. We'll get the those respective coordinates with the mapping of that dilation. Now if we apply a rule, so our function will be square root of x. The common strategy you'll do every time you create your image coordinates with the dash or the prime. I usually call them x prime, y prime. You apply the rule by rewriting the relationship, and as you do that, you rearrange those respectively to have x and y the subject, and then you will substitute those values into your original rule to get this one there. You make y prime the subject, and you're gonna end up with this equation, and you just remove the x prime, y prime, so you can match it on the original Cartesian plane. So here on the Cartesian plane, to summarize, in dash red curve you have the original function. We have that point 1 1, which we map the coordinate to 1 2, so it's moving it's a dilation of 2, it's moving away from the x-axis, and as a result from the mapping and the rearrangement, we get the new rule with the curve in blue. So here's the summary with the general dilation of factor B. Here's the mapping, the relations that you get, and then as you rearrange to make x and y the subject, that's what you will get here, and the new rule will be simplified that way. But if you just remember that mapping relation and rearrange to make x and y the subject and substitute in your y equals f of x, you should obtain this relationship or this rule. Okay. Alright, now dilation from the y-axis, so it's from the vertical axis. So what it means is if you have a dilation with a given factor, so here is 2, what you notice now is your x becomes double after the transformation. So coordinates 1 1 will become 2 1. Again, we use the same curve, y equals square root of x, which is in the dash red curve. Notice how our point 1 1 becomes 2 1, so it shifts to the right, or actually away from the y-axis. We use the mapping coordinates, write the relation, make x and y the subject, substitute in the rule, and rearrange to make y prime the subject. So here is the new the transform function, which is drawn in blue down here. So notice the factor 2 here. We're going to generalize that to a coefficient a, which is affecting your x prime. Function y equals f of x, we substitute x and y, and we'll obtain the rule y equals f of x over a to get the function of the new the transform function. All right, let's move on to the last two, which are reflections. So first is reflection in the x-axis, which is the horizontal one. Um, so by definition, when you start with your x and y, your y gets multiplied by -1 or becomes the opposite. So 1, 1 will become 1 and -1. Again, we use the same y equals square root of x. Using the mapping relations and making x and y the subject, we end up with y equals negative, hang on, let me use this one, negative y prime equals square root of x prime. You make y prime the subject, and then in the final y you just remove the dashes. Okay, so you end up with y equals negative square root of x, which is the blue curve underneath. And notice, as you do a reflection in the x-axis, it's a mirror image downwards. Here again, here's the summary. So as you change your y into a negative y, your y function becomes negative f of x. But again, you need to be familiar with the mapping here and how to rearrange it and substitute in your original function. Lastly, reflection in the y-axis. So the y-axis is vertical, so now your x will become negative x, your 1, 1 will become negative 1 and 1. We use again the same function, y equals square root of x. With the mapping, we have x prime equals negative x. We make x the subject, and we substitute into the function, and we end up with y prime equals square root of negative x prime, or y equals square root of negative x, which is the blue curve again, and it's a symmetry from the y-axis. And here's the summary again. So it's pretty much what I just did. All right. Example. So here you have your function. It's a dilation of factor 4. And in part A and B, just be mindful where from what axis your dilation will be from, or if you do a reflection, in what axis it will be done. So here you're going to do both. The y-axis is your vertical. So being vertical, you will multiply your x by 4 to become 4x. You use your mapping relations. You make x the subject. You substitute your x and y into the rule, and you're gonna have to manipulate that to simplify to this one. Good idea just to use 1 point, so the same as the previous examples. You start with 1, 1, that becomes 4, 1. You place those 2 points so you know which direction you're going to move towards to. So roughly now in blue you have the curve that's been transformed. It's moving away from the y-axis, and those 2 points show that it's a factor 4. Next one, from the x-axis. So this time it's the y that becomes 4y. You do your mapping, you rearrange to make x and y the subject. This time the one that's going to matter is your y. As you substitute the rule, the left hand side becomes y prime over 4. You rearrange to make y prime and y prime the subject. You remove the primes. Starting with 1, 1, that will be transformed to 1, 4. So 1, 1 is down here, 1, 4 is up there away from the x-axis. So you can see the direction at which the red curve gets transformed into the blue one. And that's it for the last transformations. Next session we'll look at how to combine all the transformations we looked at all together. See you later.